lucky number 13 here. So the last video you guys seen, we were on RO number 9. Well, 10's not quite ready to go. RO 11 never showed. RO 12 is definitely not ready to go. So here we are at RO number 13. Well, discouraging. We're just getting started, and I've already had a couple people that are like, "Oh, I'm not quite ready." Blah blah blah. So, okay, Mr. F sends us up. First off, he says his pass-through tune is no good. He's wanting me to change the frequency that it operates a little bit, so we're going to do that. He says his meter is broken, so he sent us this one. This is I got to cover up his name. This is one that Galaxy supplied him with. It's a signal meter on the front of a radio, and it doesn't have this plate on him. And I said, well, let me do my magic, and I'm going to build you up I'm going to use that meter back, and I'll change over meters. He wants full power wire upgrade, so he sent up, this is high temp, high strand count silicone. And he sent up this for the internal power wire distribution. It's high temp, high strand count silicone. And we're probably going to use some other high temp, high strand count silicone that's a little bit smaller, and this will be a little bit easier for us to get it through the ferrite beads. So yeah, a lot of glare coming off the bags. Anyhow, he sent up this bag of transistors. It's 4 2879s, I think. Let's take a look here. By the way, I got to give this guy credit. I called and I told him, I said, man, I've never met anybody that is meticulously labeled as much stuff as you have. This is 4 2290s. Then on the back, he's got the gains written on the transistors. And then he set up a matched pair of 455s and another matched pair of, let's see, what are these? SRF 3775s. He says he wants me to put those towards the repair credit. And I said, that's awesome. Everything's got his name on it. He sent up power poles. He wants me to use this for the fan kit. He had some extra doorknobs that he said he was just going to donate them to the shop. I thought that was freaking awesome. He's got these really cool brass threaded inserts that he wants me to use to hold the case on with. And I said, well, we'll give these a shot. We'll give these a shot using those. If not, we're going to have to use the PIM nuts. He sent up some replacement relays, which I thought was friggin' awesome. Now what he wants me to do is a little off-the-wall modification for this. This is a 100 ohm. This is more than 5 watts. This is a really good, made in the USA, old school variable resistor. And he wants me to put that here on the faceplate for him without a knob on it, so he can adjust it with a screwdriver and set it, and he doesn't have to worry about anybody messing with it. He says he wants me to upgrade components if necessary, input toroid capacitors, install fan wires, thread inserts, suggestion for coax links to the amplifier. We'll cover all of that. Install input single potentiometer. So, needless to say, this is a very, very, very nice Texas Star DX400. It's a white faceplate. There is no damage to the face. The switches on the front are in absolute pristine condition. The heatsink is spotless. The power wires are spotless. So I'm kind of interested to see what we've got on the inside when we open it up. So let me reset the camera. Let's move some stuff around and let's take a look on the inside. I love these fan kits, by the way. Very well done. We'll make sure to put a label on the on-off switch for the fan kit as well. Four beautiful Toshiba 2290s. And the inside of this thing is beautiful. You guys have heard me tell the story about the mirror board technology, about how when I first got my very first spectrum analyzer, I was trying to get some harmonics out of it, out of one of the amps that I had over here, and well, I wonder why the input pass-through, or the pass-through is a little wonky. We'll fix this. Had a little signal spur that was going on, and I figured out if I took a little piece of metal and I stuck it between the input and the output transformers, that it would cut out some of the harmonics that were going on. And boy, I thought I'd just discovered God walking on water. I call that mirror board technology. I remember that very well. And well, about a month later, I go and I open basically a Texas Star like this, a white label DX400, and or maybe it was a Black Widow or something, but it had these little pieces of copper in here. That thing is clean. Okay, well, I told him, I said, I like to bypass the fuses. He says he'd like to leave those in stock play. I said, no, if we're going to do that, let's get you a breaker. Let me get over here. I think I got one just kind of sitting out over here. At least I did the other day. So let's go get you a breaker for like $25 off of Amazon. Get you like a 100 amp breaker. Put that at the battery or at the power supply. The fuse inside the amplifier is pointless. Literally is pointless, but man, this thing is just clean on the inside. Look at this. Shiny. Oh, so shiny. The heatsink fins. This is what they look like when they're new, by the way. All clean like this. There's no dust on anything. I love it. No dust on nothing. Look at that. This is the hole that he's wanting me to populate with this here. So and I'm very hesitant to do that. And let me explain to you why. I mean, he says he's a low drive guy. These were designed to have up to, you know, like a little Texas Star modulator driven into them, right? A little one pill modulator or something, 50 watts, 60 watts, somewhere in there. As soon as I put this variable in there, we're now limiting ourselves to about 35, 40 watts of drive. Don't know. We're going to go through, we're going to do power wire upgrades. We're going to replace all this coax with the 316, make it all nice and pretty. We're going to replace this wire here with 316. And I bet you that'll change our pass-through tune quite a bit just by having this be balanced. I've never seen one of these with wires on it before. But that is stock. That's the way they did it. All right. Well, pitter patter. Let's get after her. Well, we're going to take a quick look at the pass-through tune here. Let's zoom on in here. So we're seeing a 1.83. And no, that frequency is not by accident. That's there for a reason. I guess would be the best way to put it. 1.83. All right. Well, let's change a few things. I mean, that's not bad. It's not bad at all. And most people, they take that and smile and run. Let's see what happens. Okay, so we changed from a 1.18 to a 1.1. It's a lot, but not a lot. Still all the way out past the top of the 10 meter band. We're at 31 megahertz. So all we did was we switched the coaxes. We went from this to this. Is it that much that it's going to break the bank? No. No, not at all. But we whittle at things in small little integers, and it makes a difference. So this is the output power. And what they went on to do later in the business is they took the combiners and they made them say dropped on this trace, and they rode this trace around. But in this particular box, they flipped it around and the output combiner comes to this piece of coax, which then runs over to the on-off switch, because all the RF input and output's got to go through the on-off switch. So we're going to continue on. Now we're going to upgrade the coaxes from the output section to the driver section. And we're going to prep this for us installing this. So that's next. Well, here. So we've got all of our mini coaxes in as far as we can go. I went ahead and I stripped all the power wire out of this thing, and he asked me, he couldn't think of the name on the phone. I'm like, Heiko's? And he's like, no. And I'm like, strainer leaves. He goes, yes. I got you. So now what he wants us to use is this stuff. I love this stuff. Use this in the RC car world like all the time. And it works phenomenal. Okay, this is high temp, heat resistant, carry a billion amps, never break down wire. The downside to this wire, it is not very rub resistant. So outside of the cabinet, I get a little kind of, he's gonna have to be very careful about his connections here at the back of the strainer leaves. This does not like hard tight bends. It doesn't. That's why the standard PVC jacketed wire has a tendency to last a little bit longer, and that's why I still use it going out of the amp. This carries way more shit by like 3-4 times the amount of schmutz. This can carry way more poop. Okay. It's like these connectors that I did a video on not too long ago. This beats the piss out of any Anderson clip in the world. I put 1,000 amps through one of these things. The only thing that happened, the leads came unsoldered. This little 100-some amps that this thing's gonna pull, 50, 60 amps this thing's gonna pull, never even get hot. Look at how small that connector is. I just might, for the fun of it, throw a set on here for him and let him play with them. You know what I mean? Just saying, I just might do it. Just might. Okay, our next step out of all of this is we're gonna take the meter off, which means we've got to unbolt the meter, then we got to very carefully take the face off, and then I have to very carefully punch a hole for our variable potentiometer. Because Bubba, this faceplate is pristine. I have to be careful as I'm moving it around on the carpet so that the towel, so the little strings of towel don't get caught up behind the faceplate vinyl and rip the faceplate vinyl. So let me do that. We're gonna get this variable installed, like so. And yeah, you'll see. You'll see. Okay. If I can do this, I'm gonna look like a hero. This is not my first time doing this. I got all the tools to do this. This takes a quiet, steady hand and the right kind of tape. So this is our old meter. My guy says I'm very nostalgic. I like the old style of meter. This is the new one. He got it from Galaxy. So, if we're very, very careful, we can win by attrition here by simply very carefully Okay. This meter is borked. As in, like, now that I've mechanically moved it, it'll probably work, but you know, it's done. So we got good ohms on it. But no return. So throw that in the trash. Now to the faceplate. What I told him was that I would do my best to try and build him a new meter. This is the old meter. To make this work, we have to take the old meter face, lay it over the new meter face, we have to physically make him a new face like this. Okay. So that, this, all that can go in the trash. Now, lay that in there. Lay that in there. Just like shaving off a line of Coke back in the 80s. All right. Most of these meters, the faces on them, by the time they make it here, they're a little tired. I guess would be the best way to put it. And the labeling, if you breathe on it wrong, the labeling comes off. So now, these old man geezer hands I've got, nope, not right. This is not sitting down far enough for it to clear the seam at the top of the meter. So we're going to trim this down just a little bit more. You're going to see more and more of this crazy kind of stuff going on in the repair world because nobody can get parts from Galaxy. They claim, at least the rumor is that I've been told, that they're going to continue trying to build amps for the next 2 years. Believe it or not, Texas Star has been built by two Asian ladies that I think retired during COVID or something along that structure work. Work? No. Come on. Thank you. Okay. I cannot drop the meter down any further. If I do, the armature on the meter is going to rub and we're going to have problems. So told him I would build him a new meter, and he just laughed. He's like, what do you mean? I'm like, you'll see. You'll see. This is the advantage of growing up dirt as poor as a kid. That's it. And having to scrap for everything you've ever gotten. And what I mean by that is I had to spend most of my childhood pulling garbage out of my buddies' backyards or out of their scrap pile for their radio equipment and figuring out how to make it look like new again. And I've had to do that with almost everything I've ever had. Take other people's clapped out garbage, figure out how to make it work myself, and make it like new. Beauty. Okay. All right, so now a little tiny bit of tape. Whatever you do, you don't ever use super glue. Super glue is a guaranteed gonna fail. You're gonna look like an idiot when you use it. You don't ever use super glue. Ever. Ever. Just fogs up the window, and it'll make everybody mad at you on their delivery day of that piece of equipment. Okay, so old meter out, new meter in. You guys, I can't tell you how nervous I was to cut that hole in the face of that Texas Star right there. But it's in, and it's done. So, let's put the meters in it. We'll do power wire. Okay, this took a lot longer than you guys think it does. Like a lot longer. It's currently 4:41 a.m. and I'm done for right now. I'm gonna go eat something small and light and I'm going to bed. So sticking with the silicone wire idea, I went ahead and hooked you up with some silicone wire for your fan connections. Silicone here, all Teflon here. We got the variable potentiometer installed the way you wanted it, which is no small feat taking into account how thick this thing is versus the stock part. We got our power distribution all set up, and believe it or not, the heat shrink on this, on the ends of the silicone wire, is actually pretty vital to making it last a long time. So if and when you go to cut these leads, solder them, then heat shrink them, because the boot on the silicone stuff just peels right off if you're not careful. Inside the cabinet, it'll last forever. Outside the cabinet, little iffy, but taking into account how well you have taken care of this incredibly vintage piece of equipment to get it this far, I'm pretty sure you're going to be just fine. Okay, so now what I got left I have to do, you're all asking yourselves, Well, I gotta hook it up and I gotta run it. I gotta make sure all the small stuff's working. Preamp, display, lights, key in circuit, that kind of stuff. I might have to change this capacitor, and I might have to change, or wait a minute, change this cap. Might have to change this cap, and I might have to change this cap, because we're not zero beading this right in the middle of the 11 meter band. We're going to do something a little different. I'm not going to talk about that, but we're going to set it up so it's going to be useful where you want to use it. Okay, I'm done. Peace. I'm going to go take a 4 or 5 hour siesta, and I'm going to be right back out here back at work. I'll be back. Man, have I gotten teased today about my microphone batteries going bad. Oh, the video before last that I put out, the microphone battery went bad for about 45 seconds or a minute of the video. Okay, so it's changed a little bit. What we ended up having to do was having a weird second order harmonic that was coming out of the amplifier. And what I tracked it down to being was this combiner. What they did is they took two 50 puff capacitors right here, and they had one over here on this side and another one over here on this side going to ground. And the combiner was flipped around and was going to this solder pad. And then from there, I had replaced the stock piece of coax with the 316 coax, and it was attached over here on an on-off switch. Well, after messing with it, I'm like, this is dumb. The weird second order harmonic was coming from these caps. One of them is 47.5 picofarad and the other one's like 54. There's a reason that we only have 1 point of capacitance tune in the box. When I watch these new builders, they come up and you can tell, they look inside of amps and they'll see something like this and they'll, oh, I come up with something new, and they'll just do capacitance here. You only want capacitance in one spot. So our primary capacitance now is here. So I flipped the combiner around and I brought it down to the stock trace. So now this trace is an open inductor over to this connection on the on-off switch. That changed how this box runs like night and day. Then I couldn't get the input tune to come down. For some reason, they had this little disc capacitor in there. That little disc capacitor was 150 picofarad. It didn't want that. So then I had this piece of 316 coax installed going over here to our variable trimmer. Well, they had a piece of coax going from here to here, and there's no way that was working. I was seeing like 5.5 watts of reflect with 30 going in. It was horrible. Woefully inadequate. So I thought, well, let's play the inductor game. So I changed this out to a solid piece of wire. And everything laid down. And I said, okay, now we're happy, we're ready to run. I was like, geez, what a pain in the ass. It took me a few hours to work through that. It's 6:30 in the evening. I went in the house at 4 something this morning. I slept until about noon. Then I got up and I did a bunch of stuff, shipped out a bunch of packages, got all them switchers out that everybody ordered, and came back here at about 2:30 and been out here working on this ever since. I am so happy that this box is done. And it works really, really well. The highest number I've seen come out of the watt meter so far is around 600 watts, like 550 watts. But that's not the way the guy is going to run this amplifier. So we have to test the way this guy is going to run this amp. Now, that being said, we're going to run on the 2950. I've already spoke with him on the phone and explained to him the way he needs to run it with the radio he's going to use it. I'm I'm trying to dance around what's going on here without being too big of a dick about it. Let's go ahead and let's hook this up. And let's go ahead and give this a whirl and show it working. The other thing is he sent these really cool pressure brass insert fittings. They're designed to go into plastic or wood. I tried and I could not get them to go through the side of the cabinet, and I didn't feel that there was going to be enough metal mass to where they'd adequately be able to grab into the side of the case. So I went ahead and just used our 632 crush nuts. I got some screws that got paint on them right now that are drying. So when we put this all back together, it's going to have nice threaded inserts, no more sheet metal screws. These things are officially retired. Had to change a couple things, but we got it working right. Well, hell, boys and girls, we're done. Got the beautiful fan kit installed. Honestly, this is one of the prettiest Texas Star 400s I've ever seen. That's a 400V. On the bottom side, went ahead and installed the on-off labels for you. Off, on, just the way you requested. Got your disconnects on there just the way you requested. So we're not running this on the frequency that you guys are all thinking about, okay? The guy's gonna run this some other place, so there's gonna be a little bit of secrecy going on. First, let's turn the amp off. At 012. That's all I'm putting into it for drive is about 30-40 watts, right? Here's a 2950 at audio. That's our pass-through tune, which is phenomenal. So now we're just going to turn the amp on. This is in high, by the way. At audio. 450 watts, almost 500 watts. So now we're going to go up to the other frequency that this guy wants to operate at. Audio 12. Lose a tiny bit of power, but it's set up to work there. If we notice, the meter's working on the front. Audio 12. Preamp is working. So now we're going to kick on the sideband delay, where this thing is going to be used is primarily on sideband. Hello, 12, 12. At 350 watts. Hit the AM button. Hello, 12, 12. 375. Ah, the bane of my existence, the input tune. This is on high. Hello, audio. AM. Hello, audio. And sideband. Hello, audio. Okay. The reason that has been the bane of my existence is because you guys don't have any clue how much time I've spent totally farting around with the input on this thing to get it to where it was halfway acceptable. I don't know if this amplifier was just built on a frickin' Monday morning after everybody went out drinking. I don't know. I don't know. But 1, 2, it gets with it. 1, 2, 1, 2. Works just the way it's supposed to. Now, let's just say if somebody wanted to hook a different kind of radio up to it. I don't know, like an ICOM 7300 or something. Maybe, just maybe. It's not doing a lot of Hollywood watts, by the way, you guys. It's not making big power, but it's really stupid clean. So we'll take our 7300, turn the power down to 50%. Let's turn the amplifier off. Audio. Hello, audio. Hello, hello, hello. Let's go look at the front end of our ICOM. So we're looking at our SWR bridge. Hello, 1 2 1 2 1 2 1 2 1 2. It's like the amplifier is not even there anymore. Beautiful, isn't it? Hello, 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 hello. If we look at the 5-watt element between the ICOM 7300, hello, 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 hello. There is no reflect. That is what we like. It took a little bit of time to get there too. If a guy wanted to go and use this amp, we're going to hit the sideband button and the power button. Hello, 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 hello. We see our SWR bridge. Hello, 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 hello. 5-watt slug. Hello, 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 hello. Okay. What's that get us for power over here? Remember, this is somebody talking on the amateur radio, sir. A little long-winded. They'll sit there and they'll hold it down and they'll talk 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 and they'll talk. Hello, 1 2 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. Now what you guys noticed was the power come up on the amplifier. Hello, 1 2 1 2 1 2. And what I did is I reached over here and I turned the power up. Yes, boys and girls, this amplifier is set up for high drive function now. Just saying. Hello, 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 audio, audio, da da da, hello, da 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 da, hello. It'll do 400 watts all day long, every day, wherever you need it to operate. Now, where that is at is entirely up to you. I'm not interested in ever doing this modification ever again. This is a little bit of a learning curve. It's okay. Knowledge is power. I'll explain to you how to do it over the phone, but I'm never doing this again. So, at the end of the day, we have ourselves pretty much the prettiest white-faced TX400 I've ever seen. It does exactly 400 watts, and it runs everywhere this guy wants it to run. I'm super stoked, and I'm very proud of this. I've spent 2.5 days on this project. Way longer than any other person should have. But it's perfect. And I know I can send this off to this guy and never have to think about it again. And I love having that peace of mind. I really do. All tests today were performed at around 14.8 volts. Remember, that thing floats a little bit. It is what it is. Gentlemen, I want to give a big shout out to Siglent. Big shout out to Excess Power, Penta Labs, MechMan Bird, Coaxial Dynamics. A big thanks to everybody that's following along with the drama here on YouTube. And I want to give a big thanks to my Patreons. Gentlemen, this is repair order number 13. Done, and it's in the history books. I'm off to the next one. I'll see you. Click, click.